So 1900 was the year where a breakthrough happened in physics, that is photoelectric effect. Now, why it was called as a breakthrough? Because before 1900, light was almost declared as a wave. Because light, whatever the phenomenon was happening, like reflection, refraction, interference, diffraction, polarization, everything could be explained using wave theory, right? Like what you guys have studied in the previous chapter, wave theory. So now, if photoelectric effect was not discovered, then light would have been considered as a wave. So how this photoelectric effect disproved the wave theory of light? See, first thing, if suppose, let's say we have a metal piece and light keeps on falling on that metal piece. Now, photoelectric effect was instantaneous. When they measured, it was taking around 10 to 1 nanosecond. That was the time for the emission of electrons. Okay, so what they did was they took a metal piece and they started doing this photoelectric effect using wave theory. They tried to explain. Okay, now see, wave is basically energy, correct? So as energy comes and hits a surface, first thing is it will distribute, correct? That's the nature of energy. Energy likes to get distributed, doesn't want to get concentrated. So as the light hits the surface, it will diverge, meaning it will distribute. So the light keeps on falling on the metal and the energy will keep on distributing, right? So this wave theory could not explain why photoelectric effect happens in 1 nanosecond or 10 nanoseconds, whatever it is. So when they calculated mathematically, it showed that if light was behaving like a wave, it will take somewhere around 180 to 200 years for one electron to eject. Look at this. This is not at all happening. So wave theory failed. This is one case. Second, wave theory could not explain the threshold frequency concept of photoelectric effect. Because if any wave could have done this photoelectric effect, then what is the point of threshold frequency? That was the experimental observation, correct? So wave theory failed in that. Okay. And third one is wave theory could not explain how the photocurrent and intensity of light are related. Because when we deal with frequency, when we deal with wavelength and all those things, intensity of light and the photocurrent, that could not be explained. So these three things, wave theory could not explain in photoelectric effect. That's why wave theory of light was discarded for photoelectric effect. But for rest of the things like interference and diffraction, it is still a wave. It is still considered as a wave. But for photoelectric effect, it is considered as a particle. So like what we mentioned before, it's called as photon. Okay. So these are the three things which are very important, which proved that light behaves as a wave as well as a particle. That's why we have dual nature of radiation, as a particle as well as a wave. Alright. So as we discuss about photoelectric effect, there are two important scientists, very, very important scientists who contributed a lot. One was Max Planck, another was Albert Einstein. So what they did and what formulas formulated, so all those things we'll learn in the next video.